Are there any plans to invest into Java on desktop? Is work being done to make virtual threads scale better with synchronization? Is it possible to make a Java 2.0 with breaking changes in a new release? And why is MathContext so clunky? This is the second half of the AMA, where I took these and more of your questions to Devoxx Belgium to interview the experts from the Java platform group Oracle. Without further ado, here are their answers. Okay, so Kevin, one question that we got was from Niles. I'm hugely interested in GUIs. Java has two, Swing, not thread safe it says, and JavaFX. Which one is better? Or do we need any other safe feature-rich frameworks for GUIs?
Okay, sure. I'm glad you asked me that. So first of all, let me clear up a misconception. Swing and FX have a very similar threading model.
Okay.
Both of them require you to do the UI operations on the application's thread that's presented by the Swing or the JavaFX toolkits.
Okay.
So on the Swing, you have the event dispatch thread. On JavaFX, you have the JavaFX application thread.
Yeah.
You need to do all of your operations on that. That's true of most UI frameworks.
Yeah.
Now to get to the actual question, which is, which one is better? Well, they both have their strengths, and you can use either or both of them. We're maintaining Swing, and we're still maintaining and developing JavaFX.
Yeah.
What I would, recommend is look at what your application needs. If it's an existing application, and if you want to use existing Swing UIs that other people have built, or if you have an existing Swing application, then continue using Swing.
Okay.
Or if you're doing a new application, you might look at JavaFX. But one thing, you don't have to choose necessarily. You can mix them. So both Swing and JavaFX can be intermixed in the same application. And in fact, here at Devoxx, I'll talk about that. I actually have a talk this afternoon.
Oh, nice.
About
That's good. Yeah, so I can link that later in the video description. Right, so each UI framework has like this component where you can embed basically the other.
Yes, exactly.
Yeah, exactly, right. Yeah, good point. Okay, another question was, actually a series of questions. Are there any plans to invest into Java on desktop?
Well, we're already doing some investing on Java on the desktop. We have people working actively on both the Swing toolkit and the JavaFX toolkit. We're improving both of them as new platforms come out. We're making sure we support them. We're maintaining them, and we're also adding new features to JavaFX. Yeah. JavaFX also already has a rich set of features. It's got web and media interaction. You can do animations, effects. There's lots of things you can do with that, and we're continuing to improve it.
Nice. Yeah, it's good to hear. On the part about media, there was actually also a question. When will Java get some media processing capability, like the ability to playback videos, at least the ones with non-patent encumbered codecs? And I want to advance, so there was like a little of a discussion about that post. So the person is aware that JavaFX has a media player, but like the amount of codecs is it's not that wide, right? I think you mentioned like Opus codec and some other things.
Yeah, there's a few things that we're going to be looking to add to that.
Yeah.
So yeah, he's right. We do have a JavaFX media component, and we support a few codecs, and we're going to be adding to that as we can.
Oh, that's good. Yeah, that's good to hear. I think the last one also on the similar topic is when will AWT, of all things, get WebP image support, or AVIF?
So actually, it doesn't mean AWT, even though that's what he asked. It's Java 2D that has the image codecs. Okay. So the image I/O framework in Java 2D allows you to load images in a variety of formats. We include, bundled with the JDK, support for a few, like TIFF and PNG, JPEG, and the like. You can write your own. You can plug in your own. So while we have no plans to support those codecs, you can write your own and include it with your application.
Okay, cool. Thank you very much, Kevin.
All right, thanks, Nikolai.
Yeah. So, hi, Alan. Thanks for being here.
How are you?
I'm fine. Hope you too.
Nice to be back at Devoxx.
Nice to be back at Devoxx. Last day.
Yeah. But a lot more people here on Friday than I've noticed in previous years.
Yeah?
Yeah.
It's good. I mean, they put the high-profile speakers at the very end, right, to give people an incentive to stay. I think Brian has like
Brian
the last
talk. Yeah.
Yeah. Okay, so we had a few audience questions about virtual threads, and since you've been involved with that, I thought I'd ask you.
Okay.
One of them is like the first one is more introductional question. Which are the use cases of platform threads and virtual threads, and how to choose between them?
Which is a really good question. Do you hear all the noise behind me?
Some of that, yeah.
Yeah, that's more than 1,000 people trying to get into a room that fits 800. Now, if every one of those persons were actually attendees were a virtual thread, we'd fit them all in the front row. So if you have concurrency that's actually going to be thousands or tens of thousands, good use case for virtual threads.
Okay.
replacing existing code where you've got a couple of hundred existing threads that are mapped to platform or OS threads, just replacing those with virtual threads, not a good use case. So, the power of virtual threads comes from their number. So if you've got tasks that block a lot, do networking operations, do waiting a lot, great use case for virtual threads when there are many thousands of them.
Okay.
You're not going to get the benefits of virtual threads if you've got things like code that's very compute bound, more intended for things like running in parallel with streams, that kind of thing. So virtual threads is for very highly concurrent code.
Okay.
And concurrent rather than parallel.
Oh, right, yeah. Ron wrote this article.
Right.
I'm going to link that in the description where he distinguished between parallelism, concurrency. I think that was very helpful.
Right. I noticed yesterday in a couple of questions from people is those two terms. It's good to get those right in your mind.
Yeah, exactly. And so then virtual threads are for concurrency, for highly concurrent situations.
Exactly.
And everything else. Okay, that makes sense. Let's see what the next one is. Virtual threads at the moment suffer from the synchronized thread pinning problem.
Right.
Is there currently work done to fix that in the next Java releases? If yes, is there an ETA? And I want to add, can you also explain a little bit what synchronized thread pinning problem is?
Okay, so right, so there is. We like to say there's a quality of implementation issue at the moment with what is released in JDK 21. If a virtual thread parks while holding a monitor, it cannot release the underlying carrier thread to do other work.
Okay.
So if let's suppose you're blocking waiting to establish a TCP connection, but you're holding a monitor, we can't release the thread to do other work.
Okay.
So that
that means it works correctly, but it doesn't scale.
Exactly.
Okay.
And well, there's other effects of that, but you essentially is if everything is synchronized like that, then the amount of concurrency is limited to the number of carrier threads.
Yeah.
Now, to your question, so there is work going on this. There's actually two efforts. One is the big effort, which we call the Java Object Monitor project. It's re-implementing. Jump. So that is a multi-person years of work with lots of unknowns and challenges to work out. It's re-implementing Java monitors in Java, and having more of the runtime and something as in Java means you've got to deal with a lot of issues and things like that. So there's a whole bunch of stuff is going to come from that. So that's the long-term effort. Then the short-term effort is to change the existing monitor implementation in Hotspot to be able to release the carrier in certain conditions. So I mentioned about parking while holding a monitor. That's a case where we want to release. Another one would be a contended monitor wait. So some thread is holding a monitor, some other thread wants to enter it. It's contended. It has to wait. And the third one then is object.wait when you're using wait and notify all.
Yeah.
So there's three pieces to that, a colleague of mine, Patricio, is actually working through the first two of those at the moment. So looks promising. We can't claim success yet, but it's not a significant change to get that to work.
Okay.
So we'll get that, we hope, working in the short term. Short term is vague, remember?
Yeah. I'm not trying to make promises.
You can't pin me to a release because it would be irresponsible for me to name a release. But there's good hope for this one, and so that will provide relief to this issue. So one thing just to say, just on this general problem, is there is quite an awareness, I think, within the ecosystem based on the hundreds of blogs and articles that we've read about this, that people are aware of what this issue is, but people are overreacting a little bit in that it's like, oh, I've got to replace all my monitors and use to synchronize in my code. No, you don't. If it's just used to guard some data structure in memory or something like that, then those monitors just work just fine. It's really it's where it's more important is holding a monitor when doing I/O operations. That's really where it kind of hurts. Yeah. So, and I/O operations
because you don't want to unmount anyway when you're doing heavy compute stuff. That doesn't matter. But if you do file I/O, then you do want to unmount, and then the pinning is actually hurting. Otherwise, the pinning is
Now there's other subtle forms of pinning that come up that'll need longer term thinking. That's things like doing blocking operations in class initializers. That's a hard problem. But for the short term, it's the things I mentioned will provide relief in that area, and I think will actually help a lot of the adoption, and of course avoids people having to make changes to code.
Yeah, that's good. Okay, let's see the next one. So another one is, when do we get control over which set of carrier threads a virtual thread may be scheduled on, or even a custom scheduler?
Right. So we don't have specific plans for exposing anything in this area. We did in early access builds for more than 2 years actually expose an API that allows you to replace the scheduler. So out of the box, the virtual thread uses a fork join pool under the covers. It allows you to put in your own scheduler in the form of your own executor, essentially. Which, we didn't get enough feedback on that, and that's actually not the complete solution. So we were cautious and we removed that before we actually made it a preview API. So it's an area that we need to think more about, because it's a dangerous thing. Because what it means is arbitrary code running at very, very critical points in the runtime. Like we talked a few minutes ago about locking operations and pinning. So if you're doing monitor operations, do you really want to actually go and return control, let's say contended monitor, return control back to arbitrary code to execute? Whoa, needs thinking about that one, because all sorts of issues can actually come up with that. There's more to the story as well, which is people that look for this. They're coming from different areas, but one thing people have asked for a few times is they're interested in things like doing their own time-sharing scheduler and doing preemption and forced preemption and things. So we have the infrastructure for that, but we haven't exposed it, and we need to think through about the implications of doing this, because you expose something like this and things are going to come.
It's like once that cat is off the bag, you're not going to get it back. Like once it's public, it's public.
There's another aspect to this as well, and I think where some of the people asking for this are coming from is they're trying to mate maybe a reactive async type of core with some other user code that they want to run in virtual threads, and they want some kind of control around that. I can sympathize a little bit with some of those use cases, but it needs a lot more thought. It is dangerous to expose this feature. And there's actually a whole bunch of other aspects of this topic as well that I won't get into. As usual, it's complicated, but it's being considered. Right, and but it's one that we have some understanding about, but I think there are higher priority things. It's going to take the ecosystem a while to swallow this feature, and I think custom schedulers further down the road is something we'll talk about again.
Okay, good. And last question: why developers of web frameworks like Jetty, etc. So the grammar is a little bit screwed up. Let me try to fix it. Why are developers of web frameworks like Jetty saying that they don't want to use or adopt virtual threads, and claim that they don't improve performance while introducing more context switching? So basically, they're contesting, does this thing even really help? I wasn't aware that Jetty is saying that. So way back maybe 2 or 3 years when we did early access builds, I remember the Jetty folks published an article. They have their existing code. They have their existing core. They do all their head of line blocking and that kind of thing, and they do non-blocking I/O with selectors and things. So it's probably painful for them to actually migrate. And I don't know what experiments they actually did, but several of the other frameworks are in that sync. They've got something that's actually working, it's scaling, it solves the problems that they have actually run into, so it would be a challenge for them to actually re-implement their core. So I think that's where part of that question is coming from. I then look at the Helidon folks, which is they were less shy about replacing their core, in that they started off early trying to make use of virtual threads with their existing core, and they ran into a lot of issues. Just a lot of the infrastructure they were using wasn't suited for running in virtual threads, because it was having a lot of per thread
thread locals with native resources and things like that. It just wasn't a good fix. So they decided, well, let's experiment with rewriting this core completely with blocking I/O and virtual threads. And suddenly this thing called Helidon Nima, or I think they're calling it Helidon Web Server, was actually born. So that was actually interesting for us because it was the first, and maybe it's the only one so far in this early adoption of this, that is re-implemented their core completely to use virtual threads. What's interesting about it, and I showed it in the presentation yesterday, is they've published a lot of interesting benchmarks where they actually, and it's up there with the existing frameworks in terms of some of the benchmarks that they were running. So that was actually quite impressive. There's some academic papers in this area as well, comparing things like event loops and event I/O with these kind of user thread models, and it makes for interesting reading. So I can't answer the specific that's being asked there because I don't know what's behind that. But it's certainly possible to re-implement your core and actually get results that are actually comparable.
But it also makes sense that these projects are not like super eager to do that because they have something that solves the existing problem very well, and it's a little bit of an unknown what exactly will they get once they've done this multi-month or maybe year project of like re-implementing everything with virtual threads. So I can see where they're not, just like throwing out the old stuff. Let's do this.
I'm not expecting people to throw away code either. So it's so other interesting things in this area is come back to the virtual thread implementation is we've done quite a bit more exploration of more tightly integrating I/O events with the virtual thread scheduler, and there's some promising results actually come from that, particularly on systems where the CPU load is quite high. Let's say network traffic where you're doing a lot of crypto, TLS, SSL type. So some interesting results from that hopefully we might get into an early access build at some point.
Oh, nice. Cool. So I'm looking forward to that. Yeah. Thank you very much, Alan.
Okay.
I see you around.
All right. Enjoy the rest of your day.
Yeah, you too.
Before we get to the last part with Stuart, I want to do a quick lightning round and briefly answer some more of your questions. If I remember correctly, GraalVM, including Nativeimage, will be merged into OpenJDK at some time in the future. Any news on that? So, I'm not sure that's quite the plan. I think Project Leiden is looking into developing a concept that might lead to eventually either Nativeimage being merged as is or something similar to Nativeimage being redeveloped in OpenJDK. I'm not sure what exactly the plan is there. Either way, check Project Leiden for news on that. Azul has CRaC. I think condensers are somewhat similar. Any news on that or maybe a timeline? So again, condensers are part of Project Leiden, so look into that. There was actually a question at Devoxx Belgium about CRaC that Brian answered, and I'm going to put that now.
So the question is, how is this related to CRaC? So they're related in the sense that they're exploring the same goal. So Project CRaC basically says, let's assume a checkpoint mechanism that's outside of the JDK, whether it be CRU or some cloud-based checkpoint mechanism. Let's run the application up to a certain point, freeze dry it, and then restore it. And then that may not work because you may have done things like open sockets. So you have to register handlers for things that have to be redone at restore time. So I think CRaC is an interesting exploration. I'm not particularly optimistic about it because it is not something that allows you to validate that your program is correct through any sort of like sensible analysis. You sort of have to debug your way into correctness by trying things and seeing what fails. The problem with CRaC is that it's trying to interpret old code with new semantics and hope everything is good. And if it is good, great. It gives you great performance numbers. If not, you just have broken code. And maybe if you're lucky, you get an exception. But maybe if you're unlucky, you just get wrong answers. And those wrong answers come from assumptions that are violated deep in libraries that you didn't even know were part of your application. So I think CRaC is it's a good exploration. I think it's but I'm not optimistic about it as a programming model. I would much rather give people a programming model where if they, whatever code that they have will run correctly 100% of the time, and then if they do some more work, they can make it run faster. CRaC tries to make things run faster, potentially at the expense of correctness, and I don't like that trade-off. But I think it's an interesting exploration. I'm glad it's going on, but I wouldn't bet on that direction.
Okay, did it happen? Yes. Why does Java still not support metaprogramming? Not sure what exactly you mean by metaprogramming, but I want to recommend to look into Project Babylon, which is very fresh and very new. There's also a great talk from JVMLS on that topic that I'll link, and that might answer your question, not exactly sure. Then we have a few interesting questions that all touch on the topic of breaking Java or versionings. This is really great. As a learner, I always like stability in the technology. Java is continuously evolving with new features and additions. Can I expect stable Java versions ahead? Okay, so do we get stable Java versions? Next question. We are seeing some APIs removed that have been deprecated for 10 or more years, and yet there's a lot of Java code in industry that is old enough to use them. What factors is Oracle weighing while trying to preserve backwards compatibility and trying to move Java forward? So this is like a more middle of the road concern. So there are changes being made, some of them potentially backwards incompatible. And the last question is it possible for you to make Java 2.0 and as C# make a breaking change in new releases? So this all touches on the concept of Java's backwards compatibility. In general, Java wants to be very backwards compatible. Not fully, because clearly some things changed, right? The single underscore used to be a legal variable name, and now it's not anymore. The security manager is slowly being phased out. Concurrent mark sweep is gone. So clearly there are changes being made that require a change in code. But the idea here is to keep that as minimal as possible, right? So no, there will not be a Java 2.0 with a breaking change just for this one feature. For once, because that will invalidate a lot of investment, a lot of code in Java that already exists out there. But it will also break this promise and will break the dam, because then every other feature might as well also break backwards compatibility, right? So yeah, I'm sure that's not going to happen. And Java will remain stable. But at the same time, yes, some things are removed, some things are deprecated, and the consideration there, I think, is it has to hurt a lot. Somebody, that's not necessarily us users, that might also be the development process within OpenJDK, but something somewhere has to hurt a lot to remove something that is still actively used. So, removing stuff that nobody uses anymore, that's a little bit simpler, but overall there must be some big gain for removing something that is actively used. So that's the consideration. And that's very vague. For more detailed questions, we'll have to ask Brian the next time we get him. Okay, and then there was a last question. Can we see Java again in cutting-edge technologies, AI, robotics, 3D engines, VR, HPC? I don't know what that is, though. Like the old times. Supporting Java platform in multiple fields would benefit the community more than introducing new syntax features. So that's a good point, right? So in recent years, Java has very much become, not recent years only, like in the recent decade and a half, has very much become the language of server backends and the cloud. And that's good, right? That's a big portion of, where software development is going, and it's good that Java has a strong foothold there. But yeah, absolutely. Java is a general purpose programming language and should and wants to be present in all these other areas. But the way to get there, it's not to show people fancy marketing material that this is what they're supposed to use now, or, to show it off at Java 1, or to, just force people into, no, you cannot, program your game in Unity. It must be Java. Clearly, that's not going to work, right? The way to get people to use Java in these fields is by making the programming language solve their problems in those fields. And sometimes that can be syntax, but a lot of work in recent years has been going on, and we've seen that in the last AMA with Brian, into Valhalla, into Panama, and those things do tackle AI, and for example, or robotics, because they're closer to the machine level. So these new features, syntax or not, are being developed to make sure that Java stays relevant in the cloud and becomes stays or becomes more relevant in these other areas.
Okay, so we're here with Stuart Marks. Thank you very much for agreeing to do this.
Okay.
I only got two questions for you.
All right.
The first one is, why can't I set MathContext globally for all big decimals, and then adding them everywhere is a real pain?
Yeah. Okay. So yeah, I've used that API a little bit, and when you need MathContext, you need it. The first problem is we do not want any global variables, because different threads can be doing different big decimal computations concurrently, and if you had a global, then they would interfere with each other. And in general, that's why global variables are bad, especially if they're mutable. Because you have all these different settings, and so if you had a global setting, then you would need to mutate that somehow, and that's a rat's nest. Okay, so what are alternatives to that? Because right now you need to pass MathContext into every computation that you do in order for that to apply.
Yeah,
So
I think that was the root of the complaint.
Right, so how can you get away from that? Okay.
So let's get the take.
Yeah, we should see what's going on there. This is.
So I think it's not going to show up too much on the mics.
Yeah.
But it's probably going to show up a lot in our mental space. Okay, let's keep going though. Let's try. Maybe I cut this later. We'll see. But also, this is the conference vibe.
Yeah, this is right. Lots of stuff.
Oh, by the way, there would be much more going on here right now. We're recording this during a talk session, so all the diligent developers are sitting somewhere up there in the cinema rooms, listening to new stuff. That's why it appears so empty here.
That's right. And the rest of us are just doing videos and stuff like that.
Exactly. It's super crowded in between the talks.
Yeah.
Okay, right. So you said what other way would there be?
Yeah. So the problem is what are some programming constructs that you can use that essentially apply implicit arguments to things? Okay. So if you don't want global variables, then what could you do? Well, you could do thread locals.
I was going to say that scope values.
Yeah. Well.
Okay.
So that's the next thing. So things like thread locals or scope locals are good. Or scope values are good for things like context, which everything, like if you have if you have a session context in a web server, right?
Yeah.
Everything you do has to be relative to some session, and so you just don't need to pass that around that much, right?
Yeah.
But with MathContext, that's not clear because it seems like maintaining that might be difficult because different computations might require different math contexts.
Yeah.
And so if you have something implicit in the environment, then that has to interact somehow with the explicit one. So does it override or does it merge?
Yeah.
And then now you're reading the code and you're saying, well, why is this rounding mode going the wrong way? Because there's some hidden state that your computation is now depending on.
And the other way around as well.
Yeah.
If you make a change somewhere, how can you see which code is impacted? Now I changed the math context here.
So,
which computations do I have to check?
Yeah. So that's exactly the problem, right? And then the other place you could put it is in the objects themselves, and that's probably wrong as well because a big decimal is a nice class because it represents a value and its object model is very simple. It has a significand and it has a scale. And that's it, right? If you tried to put math context into that, then different things that actually, remember this whole business about equality of big decimal? Now it's like, do two big decimals that have the same numeric value but different math context equal? Right? So no, math context does not belong in the big decimal itself either. So this is, it's a tough problem with programmability. Yeah. So that's why it's explicitly on every computation because that's bad, but I'm not convinced that trying to put it somewhere else is actually any better.
One approach that I can come up on the top of my head is if the big decimal computations are few and far between, what I have in mind does not help. But if you have a bunch of them in one place, you could write something that is let's call it big decimal math that I create with the rounding, and then I do not call big integer 1 add big integer 2.
Yeah.
I call my custom big integer math thingy .add, and then I add the big decimals, and then it passes that in everywhere. But that's like a library solution that everybody can try at home. That would not need support by the JDK. Okay, interesting though, yeah. So as we often have in these conversations, there's a thing that seems like, why is it not simply different? And the reason for that is it's not simple. In that vein, by the way, is the second question, which is my personal beef that I'm bringing to the table.
All right, okay.
So you have the hashing data structures. There's a little bit of background. Hashing data structures have a non-obvious way to size the underlying array. And if I want to have a hashing data structure that can take exactly n elements before it starts to resize, it's actually not like with the old API. I actually had to do some math in my head or in the machine to get the right thing. So now we have vector methods that say, okay, look, you want to have a hash set for a specific number of elements before it starts resizing. We're going to have hash set dot. And now comes my complaint. Why is the new method called hash set dot new hash set 16? Why is it not hash set for number of elements or something?
Yeah.
Why is it so?
Right. Okay. Yeah. So every naming decision has a bunch of stuff behind it. Okay.
I want to be involved in those from now on.
Okay. So what's the best way to have to create a hash map that can accommodate n elements? All right. Well, static. Instead of trying to add overload constructors, let's add static factory methods.
Yeah.
So the first thing we need to know is what what collections actually have this problem where they take the table size instead of the number of mappings. Okay, so there are 5, right? So there's hash map, hash set, linked hash map, linked hash set, and weak hash map.
Oh, I didn't know about the last one. Okay.
Yeah, okay. Crucially, linked hash map is a subclass of hash map.
Okay.
Okay, so remember that. Okay, so now let's say, all right, so let's add a static factory method somewhere that creates a new hash map with a sufficient size to accommodate the requested number of elements.
Yeah.
Okay, and then inside, basically, the technology in this is very simple. Let's just get the expression right and put it in the library. So we do the division by 0.75 and then do the rounding up properly and so forth. Okay, that's not that difficult. Put it into a static factory method somewhere. What class should that be on and what should it be called? Okay, so we could put it on the map interface because there's static factory methods on map, but it's a little weird because if you want to create...
map shouldn't know its hash map implementation.
Yeah, it's a little strange to have it's kind of a backward dependency. So the other obvious place is, okay, so if you want to create a hash map, then put a static factory method on the hash map class. Okay, great. Okay. And then same with linked hash map. Okay, linked hash map gets a static factory method. Now, what should they be called? Okay, so now, you want a component to say what it does. So new or create or make or some verb that says you're making a new thing.
My proposal is something like a hash map dot for number of elements or whatever. Like so say that what the parameter is about. But then you have, and I think that was what you were going for probably. Like then you have hash map and linked hash map. And then if the name of the collection doesn't show up in the method name anymore, they have the same static method. The static method with the same name. And that's, I think, generally discouraged because it can be mildly confusing.
Right. Okay. So that's it. So suppose, yes, that's right. So suppose we said hashmap.of 4 would create something, hash map of size 4. And the problem that occurs here is that static methods in Java are actually inherited.
Yeah.
And so suppose you said hashmap.of 4 created a Java util hashmap.
Yeah.
That would get inherited by linked hashmap. And so if you said linked hashmap.of 4, you would actually get a hashmap, not a linked hashmap.
And you can, can you not overwrite?
Okay.
Overwriting does not exist in that phrase. Yeah?
Okay. So now the requirement is that every subclass of hashmap, both inside the JDK and outside the JDK, must have an of method on it. Otherwise, you get the wrong thing. So suppose I said, my special hashmap is a subclass of hashmap, and then I said, oh great, I can say my special hashmap.of 4. I don't get my special hashmap. Yeah. I get a hashmap. So
you wanted
kind of weird.
And you wanted this to show up then in the method name. So at least the method name tells me my special hashmap dot new hashmap still kind of tells me as a user
exactly.
Well, I'm probably getting hashmap. And new hashmap with size is then getting a little bit long.
Yeah,
maybe?
And exactly. So that's the impetus for having the actual class name in the method name.
Yeah.
So, and also it makes it, if you're doing this a lot, it makes it easier to static import. So it does seem redundant to say hashmap.newHashmap.
Yeah, although my main gripe is not the redundancy. My main gripe, actually, my gripe, period. No! Hey, Church!
Oh, hey!
All
right.
Yeah, that's good. So
it's been ages.
So my gripe with that is that you will have if you ever have another reason to create a static factory method, the names will collide. So from my point of view, the big strength of static factory method, one big strength is that you actually can put the thing that the constructor that this construction does in the name of the method, and you can give it like a good name, and then the other static factory methods have another good name, and then you will see, oh, this one does this and this one does that. And so this is to me like a big strength of why I use static factories methods in the first place, because they're more informative than new hashmap 4, where you don't know what does the 4 even do.
Yeah.
And so that felt like a missed opportunity to have something that basically looks like it's called like a constructor.
Yeah.
And that's it for the second half of the AMA. If you didn't already, make sure to check out the first half where we interviewed Brian Goetz about Java's language development. I hope you learned something new. If you did, leave a like so more Java developers get to see this video. I'll see you again in the next newscast. So long!